This question is clone graph. So you are going to have a deep copy for the graph, and this is a node. So let's look at the class node. You have integer value, list of node for the neighbor. So again, this is going to be a copy for the current node and its neighbor. So you're gonna have a map. Map is going to store the key is going to store your current node, and the value is going to basically it's going to store the value and also the neighbor. And queue is going to just keep appending and see do you traverse this one or not. And if you do, then just not hit it. If you does not traverse this node, just add into the queue. So let's start coding. So if no equal to no, then you don't want to return anything but no. And the hash map you're storing no map equal to new hash map. So and also I have a queue. Now queue equal to new linked list. And then I'm going to just add the current node into the queue and also put my current node into the map. So I'm going to say put node, comma, and then so the current node is represent the just look at the current node is represent a value and then also a neighbor. So for its neighbor, currently is empty, right? You will have to traverse once you what uh, once you explore, right? So I would say new node, and it has to be node.val and then empty release. All right, so I have everything. So now I just have to what traverse the queue. So well, queue is not empty. Then I'll just keep traversing. No. What's that called? Current equal to queue.poll, and then I will have to traverse based on my neighbor. So this is my current node. I'm traversing my neighbor. So it's gonna be node, val, and then it's gonna be current dot neighbor, correct? And then imagine you don't have neighbor. Imagine you don't have neighbor. What you need to do is you want to uh, literally just ignore this for loop, and then you want to return not the node is actually map that get node. Because if you return a node, it's going to be represent this one. If you say node dot get node is represent this one. So yeah. All right. So back to here. So imagine you have a neighbor. Imagine you have a neighbor. You're going to find out does your map has this node. If your map does not have it, right? You want to say map dot put the child new node, and then it's going to be child dot val, and then assign a array list just like beginning. And then you want to add into the queue because your map doesn't have it. Definitely not in the queue. Queue dot offer child. Okay. So once you have all this, and then if the current child is in the map, you want to do the neighbor, right? Because we haven't add anything to the neighbor. This is where you want to add the neighbor. So the neighbor is going to be based on your current node dot neighbors dot add, and then what do I need to add for the trial, right? So trial has neighbor, right? Trial is node. Node has neighbors, so it's gonna be add the node for the trial. So map dot get trial. So this will be the solution. So if map doesn't have trial, you add it and then initialize to empty and you put into the map. So if and then you add the current value. So you find out the current neighbor. current neighbor, and then add your child into the neighbor. Okay, I might be wrong, but yeah, all right. Well, the time and space should be all of n. Traverse all of the node and then um traverse all of the node require all of n time, and saving all of node require all of n space. So there's a solution. All right, see you.